Completing the square is a process we often use to graph quadratic equations. We do this because it puts the equation in terms of key features of the graph. Let's consider an example here where we've got x squared plus 6x take 10. If you pause here and check, you'll find that this won't factorise using conventional methods. Let's have a look at the process of completing the square. The first thing we do is we check for the coefficient of x squared. It's a 1, so we can follow a process we're about to do now. If it wasn't a 1, what we'd have to do is factorise out the coefficient of x squared in front of the whole expression. Let's have a look at the coefficient of the x value. It's a positive 6. So what we do is we look at a half of 6 and we put it in the bracket, and the bracketed expression becomes x plus 3 all squared. Now that's not the solution yet. What we need to do is consider what that bracket squared is going to give us. It gives us x squared plus 6x plus 9, and it's advised that you check that to make sure that bracket expansion is correct. So the expression in blue does not match our beginning expression, so we need to make some adjustment. We need to consider the plus 9 and where it came from. Now it came about from 3 squared. So what we'll do is we'll remove 3 squared, and of course that's always the half of the initial coefficient of x. So that gives us x squared plus 6x, very close to our beginning expression. We can see here that our solution in the second line, and we're actually completing the square, is very close to our beginning expression. What we need to do is put the take 10 at the end, and now the two expressions are equal to each other. Let's consider where all this came from. To complete the square, we need to consider the coefficient of x. We halve it. A half of 6 gives us 3, and we can see that in orange. We then need to subtract that value squared, so you can see in blue that we're taking away 3 squared. The final piece of this process is to then place the constant, in other words the value without an x, at the end of our expression. So in this case we've got our take 10 that we place at the end of our solution. We then simplify this to get our final answer. We can see that 3 squared is 9. At the end of the expression, by subtracting 9 and subtracting 10, that gives us subtract 19 outside the bracket. So our final solution, since we've now completed the square, is x plus 3 in brackets all squared minus 19. Now the connection to the graph of the quadratic equation that we spoke about earlier is that the value in the bracket plus 3 can help us find the line of symmetry, or the x value of the turning point. The x value of the turning point will be the opposite of that, so it'll be negative 3. The minus 19 at the end helps us find the y value of the turning point, and the y value of the turning point in this case is negative 19.